Also, please like, leave a comment, and share the video to help spread this free series of videos. Thanks for watching. This video will once again cover the topic of VLANs. Although we've already covered the most important basics about VLANs, there are still a few more things you should know about VLANs for CCNA. This is going to be a long video. Let's get right into it. First off, here are the topics that will be covered in this video. First off, a little addition to the previous video, I will show you how to use the concept of a native VLAN on a router and using router on a stick or inter-VLAN routing. Next up, we will look at a few Wireshark captures to see the .1Q tag. Wireshark is a great tool for network engineers, so I plan to use it at various points in this series to help you understand these. After that, we'll look at the final method of inter-VLAN routing, which is layer 3 switching, also known as multi-layer switching. I've always told you that switches are layer 2 devices, and don't use IP addresses. However, many modern switches are actually layer 3 capable as well, and I'll talk about that in today's video. These are two topics which have actually been removed from the CCNA exam topics list. DTP, the Dynamic Trunking Protocol, and VTP, VLAN Trunking Protocol. I was planning to cover these in this video, but due to the length of the video, I'll reserve a separate video for it. Although these both have been removed from the exam topics list, I think it will probably be important for you to understand these topics, at least at a basic level for your CCNA. And you may actually see some questions about them in your exam, even though they have been removed from the topic. However, I will give just a basic overview of each. There is no need to go in depth. Before getting started, I want to say make sure that you stick around to the end of today's quiz. From now on, I'll be featuring one bonus question from Boson XC, Boson set of practice exams for the CCNA. Look forward to that. If you want to get a copy of Boson XC for yourself, by the way, follow the link in the video description. No other practice exams help you get ready for the real exam like Boson. So if you can, I highly recommend getting and using it to prepare for the exam. Let's move on to the first point, using the native VLAN feature on a router. I said in the previous lecture video that the best practice is to set the native VLAN to an unused VLAN, as the native VLAN feature can cause some security issues. We'll talk more about network security later in the course. However, if you want to use the native VLAN feature, let's see how to use it on a router. The native VLAN feature does have one benefit. Because frames in the native VLAN aren't tagged, it's more efficient. Each frame is smaller, so it allows the device to send more frames per second. In the previous video, I set the native VLAN to 1001 on switch 1's G00 interface, and switch 2's G00 and G01 interfaces. So just for this demonstration, let's set them back to a use field, VLAN 10 on all trucks. There are two methods of configuring the native VLAN on a router. There are two methods of configuring the native VLAN on a router. Let's take a quick look at them. First up, you can use the command encapsulation.1q followed by the VLAN ID, followed by native. This tells the router that this subinterface belongs to the native VLAN. It will function just like the native VLAN on a switch. It will assume untagged frames belong to the native VLAN, and frames sent in the native VLAN will not be tagged. The second option is to not use a subinterface at all, but just configure the IP address for the native VLAN on the physical interface of the router. The encapsulation.1q command is not necessary in this case. Okay, let's look at each option. First, I will configure the first option. Here it is. On the G00.10 interface, I configured encapsulation.1q10 native. Note that this is the complete topology from the previous lecture video, so the IP address is already configured. The only change is that I added native, the encapsulation.1q command. Let's take this opportunity to look at a Wireshark capture to demonstrate the native VLAN. This PC in VLAN 20 has an IP address of 192.168.1.65. This PC in VLAN 10 has an IP address of 192.168.1.1. I will use Wireshark to monitor this connection between R1 and switch 2. Wireshark will capture all frames of this connection, both directions. So we can take a look at what traffic is passing. Let's send that in. We'll first look at the capture of the ICMP echo request message as it goes from switch 2 to R1. It will be in VLAN 20, and it's being sent to R1 for inter-VLAN routing. Here's the Wireshark capture for the ICMP echo request as it goes from switch 2 to R1. First off, you can see the source and destination IP addresses here. Now let's look at the Ethernet header encapsulating the IP packet. Specifically, look here. Type 802.1q virtual WAN, and notice the hexadecimal 8100 value here. I said in the previous video that .1q is inserted after the source MAC address field, and that is where the type field usually goes. This here is the TPID field of the .1q tag. Under it, these are the rest of the fields of the 802.1q tag. First is the PCP, priority code point. It has a value of 0, so no special priority is given to this. Under it is the DEI, drop eligible indicator. Again, a value of 0, so it won't be dropped during times of network congestion. Next is the most important field, the VLAN ID, which is 20, as you would expect. The PC that sent the ping is in VLAN 20, and it's not the native VLAN, so that's why this field is tagged. Finally, under that is the normal type field of the Ethernet header, indicating that an IPv4 packet is encapsulated. It normally comes after the source MAC address field, but now the .1q tag is between. Next, let's look at the ICMP echo request going from R1 back to switch 2. It will now be in VLAN 10 because the destination is in VLAN 10. VLAN 10 is configured as the native VLAN on both R1 and switch 2. So let's see what's here. Here's the exact same ICMP echo request, the exact same layer 3 packet, as it is sent from R1 to switch 2. What's different? It is being encapsulated with the new Ethernet header, but this Ethernet header doesn't have a .1q tag. This is the native VLAN function at work. Both R1 and switch 2 understand that untagged frames belong to VLAN 10, so there is no need to tag each frame with .1q. That ICMP echo request will continue to the destination, untagged all the way, because VLAN 10 is configured as the native VLAN on all devices. When this PC in VLAN 10 sends the ICMP echo reply, it will be untagged until it reaches R1, We'll then tag it in VLAN 20 and send it back to the PC that sent the request. Now let's take a look at the second method of configuring the native VLAN on the router, which is simply configuring the IP address on the router's physical interface. No need for a sub-interface or the encapsulation.1q command. Here is how to configure it. First, I used no interface G00.10. This deletes the sub-interface. Then I entered interface configuration mode from G00 and simply configured the appropriate IP address on the interface. To help you visualize it, here is the output of show running config for G00 and its sub-interfaces. First off, these commands here on the physical interface are there by default. I didn't configure it. The physical interface is configured normally with an IP address. This will be used for the native VLAN 10. The other sub-interfaces are just like we configured them in the previous video, with the encapsulation.1q command and their own IP. This will function just like the first option. Switch 2 will send VLAN 10 packets in untagged frames to R1, and R1 will send them in untagged frames also. As I said before, it is recommended that you just change the native VLAN to an unused VLAN for security purposes. But if you want to use the native VLAN, it's important to know how to do it on a router. So these are two methods you can use. You might also need to know this for your exam, by the way. Here's the network diagram once again. We have one router and two switches, or I should say two layer 2 switches. This is the icon we'd be using for regular layer 2 switches. But let me introduce you to another type of switch. This is the icon I will use for what is called a layer 3 switch, also known as a multi-layer switch. From now on, I will use either layer 3 switch or multi-layer switch. You should know both. By the way, these are the official Cisco icons for a layer 2 switch and a layer 3 switch. But I think the ones I use in my videos look cleaner and more modern. First, let's review exactly what a multi-layer switch does. A multi-layer switch is capable of both switching and routing. It is layer 3 aware. A regular layer 2 switch is not layer 3 aware. It doesn't think at all about IP addresses or anything above layer 2. It only cares about layer 2 information like MAC address. You can assign IP addresses to its interfaces like a router. Previously, we haven't assigned any IP addresses to switches, only routers. With a layer 3 switch, you can configure routed ports, which function like an interface on the router. Not just physical interfaces, but you can also create virtual interfaces for each VLAN and assign IP addresses to those interfaces. These are not separate physical interfaces, but virtual interfaces in the software of the switch that can be used to route traffic at layer 3. You can configure routes, like static routes, on a multi-layer switch, just like a router. Finally, it can be used for inter-VLAN routing. So far, we have looked at two methods of inter-VLAN routing. The first one, in day 16's video, was using one connection for each VLAN between the router and switch. This works, but if you have many VLANs, you probably won't have enough interfaces on your router. The second method was router on a stick, which uses a single trunk connection, which carries traffic from all VLANs between the switch and router for inter-VLAN routing. This is efficient in terms of the number of interfaces, just one. But in a busy network, all of the traffic going to the router and back to the switch can cause network congestion. So in large networks, a multi-layer switch is the preferred method of inter-VLAN routing. Let's see how it works. Here's the topology again. Now let's replace switch 2 with a multi-layer switch. There we go. And now let's make one more change. I've replaced the trunk link between switch 2 and R1 with a point-to-point layer 3 link. We will no longer run VLANs across it. I'll talk about this link later and assign IP addresses to R1's G00 interface and switch 2's G01 interface. But for now, let's focus on the inter-VLAN routing done on switch 2. For review, when we use router on a stick for inter-VLAN routing, traffic being routed between VLANs was sent to R1 first, and then sent back to switch 2, and then forwarded to the destination. For example, if this PC in VLAN 20 wants to ping this PC in VLAN 10, the traffic would follow a path like this. From the PC to switch 2, from switch 2 to R1, tagged in VLAN 20, from R1 to switch 2, tagged in VLAN 10, from switch 2 to switch 1, tagged in VLAN 10, and finally to the destination. However, switch 2 is a multi-layer switch. It doesn't have to send the traffic to R1 for inter-VLAN routing. It can do that with something called switch virtual interfaces. SVIs, or switch virtual interfaces, are the virtual interfaces you can assign IP addresses to in a multi-layer switch. Configure each PC to use the SVI, not the router, as their gateway address. When using router on a stick, the router was used as the PC's gateway. This time we will use the switch's SVIs instead. To send traffic to different subnets or VLANs, the PCs will send traffic to the switch, and the switch will route the traffic. We'll use the switch's SVIs instead. To send traffic to different subnets or VLANs, the PCs will send traffic to the switch, and the switch will
send traffic to VLANs The PCs will send traffic to the switch. The switch will route
the traffic. These are the SVIs I configured on switch 2. These are the same IP addresses I configured on R1 when doing router on a stick, the last usable IP address in each subnet. So these are already configured on each PC as their gateway addresses, so there's no need to change the PC configuration. Now let's take a look at the path the traffic between these two PCs takes this time. The frame arrives at switch 2. The destination is in the 192.168.1.0/26 subnet. Switch 2 now has its own routing table. So it looks at the destination in the routing table and sees that the destination is connected to its VLAN 10 SVI. So the traffic is now routed to VLAN 10. If switch 2 doesn't have the destination MAC address in its MAC address table, it will flood the frame to all VLAN 10 interfaces. But let's assume it has already learned the MAC address. So it forwards it to switch 1 over its trunk interface, tagged as VLAN 10. Switch 1 then forwards it to the destination. Now, what if the hosts want to reach destinations outside of the LAN? For example, I've added a cloud connected to R1 to represent the internet. Because switch 2 is their default gateway, any packets destined outside of their subnet will be sent to switch 2. But our previous router on a stick configurations for the connection between switch 2 and R1 will no longer work. In addition to configuring virtual interfaces, SVIs on multi-layer switches, we can also configure their physical interfaces to operate like a router interface, rather than a switch. So we can assign the subnet 192.168.1.192/30 for this point-to-point link between switch 2 and R1, with switch 2's G01 interface having an IP address of 192.168.1.193 and R1's G00 interface having an IP address of 192.168.1.194. Then we configure a default route on switch 2, pointing toward R1. So all traffic destined outside of the LAN will be sent to R1. I already covered static routes, including default routes, in previous videos, so I won't explain the concept in depth again, but I will show you the configurations once. So let's do that. Let's get into the configurations, starting first with the point-to-point link between switch 2 and R1, and then the SVIs on switch 2. First off, remove R1's router on a stick configurations and configure that new IP address on G00. First off, I delete each subinterface with this command: no interface G00.10, .20, and .30. Then I use the command default interface G00 to reset G00 to its default settings. After that, I used show IP interface brief to check the interfaces. Notice the status of the subinterfaces. It says deleted. Although we have successfully deleted the subinterfaces, they will remain here with a deleted status unless we reload the router. That's no problem though, so I'll just leave them. Then I simply enter interface configuration mode for G00 and configure the new IP address with a /30 subnet mask. I use show IP interface brief again, and you can see that the new IP address has been successfully configured. Now let's look at the switches side of the point-to-point connection. First, I reset the G01 interface to its default settings with the default interface command, because it was configured as a trunk for router on a stick because of the previous lab. Next up is a very important command, one you must not forget: IP routing. This command enables layer 3 routing on the switch. It lets it build its own routing table like a router. If you forget this command, your inter-VLAN routing will not work. Next up is another important command: no switch port on the interface. This is the command that changes the interface from a layer 2 switch port to a layer 3 routed port. Now you will be able to assign an IP address to it. So I assigned 192.168.1.193/30 and used show IP interface brief. And as you can see, the IP address is assigned to it just like a router interface. Last up is the default route pointing to R1. As I've already shown you in a previous video, the command is IP route o.o.o.o, o.o.o.o, followed by the next hop. In this case, 192.168.1.194, which is R1. I then used show IP route to confirm, and you can see that switch 2 now has a routing table, with a default route pointing to R1, and connected and local routes for the routed interface we configured. And one additional command you can use to confirm is show interfaces status, which I showed in a previous video on Ethernet switching. Notice that in the VLAN column, instead of a VLAN number, G01 displayed is R1, and connected and local routes for the routed Notice that in the VLAN column, instead of a VLAN number, G01 displays routed. Okay, now let's move on to configure those SVIs on switch 2. SVI configuration is very simple. Here are the configurations for switch 2. Use the command interface VLAN 10, for example, to create an SVI for VLAN 10 and configure it. Then assign an IP address and use no shutdown to enable it. SVIs are shut down by default, so remember to use the no shutdown command to enable them. I repeated the process for VLAN 20 and VLAN 30, and that's all there is to configuring SVIs. Very simple. Now, just to demonstrate one problem you might encounter, I created another SVI for a VLAN that doesn't exist on the switch, VLAN 40, and assigned an IP address, 40.40.40.40/24. I also made sure to enable it with no shutdown. However, look at the SVI itself. It is down, down. Why is that? Well, it's because the VLAN doesn't exist on the switch. Let's take a look at the conditions required for an SVI to be up, up. First, the VLAN must exist on the switch. In this case, we haven't created VLAN 40 on the switch, so the SVI won't become up, up. When you assign an access port to a VLAN, if the VLAN doesn't yet exist on the switch will automatically create the VLAN. However, if you create an SVI for a VLAN that doesn't exist yet, the switch will not automatically create the VLAN. Second, the switch must have at least one access port in the VLAN in an up-up state, and or one trunk port that allows the VLAN that is in an up-up state. For example, in the topology we're using here, switch 2 has hosts connected in VLAN 10 and VLAN 20, so their SVIs can go up. There are no connected hosts in VLAN 30. However, it has a trunk port, G00, which allows VLAN 30 over it. So VLAN 30's SVI is up as well. 10 and VLAN topology we're using here. Switch 2 has hosts connected in VLAN 10 and VLAN 20, so their SVIs can go up. There are no connected hosts in VLAN 30. However, it has a trunk port, G00, which allows VLAN 30 over it. So VLAN 30's SVI is up as well. Okay, next rule. The VLAN must not be shut down. Note that this is not the SVI, but the VLAN itself. You can enter VLAN configuration mode and disable the VLAN with the shutdown command. If you do this, the SVI for that VLAN can't become up, up. Note that I think you can't do this command in Packet Tracer, so you'll need a real Cisco switch if you want to try this one out. Finally, if the SVI itself is shut down, it obviously won't be up, up. So make sure to use the no shutdown command after you create an SVI, because they are shut down by default. I use the SVI. because I can't go. You can enter VLAN configuration mode and disable the VLAN with the shutdown command. If you do this, the SVI for that VLAN can't become up. Note that I think you can't do this command in Packet Tracer, so you'll need a real Cisco switch if you want to try this one out. Finally, if the SVI itself is shut down, it obviously won't be up. So make sure to use the no shutdown command after you create an SVI, because they are shut down by default. I use the SVI because they are shut down by default. I use the show IP route command again, and you can see connected and local routes have been added to the route table for the SVIs we created, all shown as directly connected to the SVI for each VLAN. Okay, so our configurations are all done. The next video will be a practice lab, so you can get some hands-on practice doing these configurations. If you have trouble remembering the commands, I highly recommend doing practice lab and doing them multiple times until you feel confident. So, if one of our PCs wants to reach a destination outside of the LAN, it will be sent to switch 2, which will send it to R1, which will take care of it from there. Note that we didn't actually configure any routes on R1 in this lab. I'm just focusing on inter-VLAN routing at this point. If one of our PCs wants to reach a destination in the LAN, but in a different subnet in VLAN, switch 2 will do the inter-VLAN routing without having to send the traffic to R1. Okay, before moving on to the quiz, let's review what we covered in today's video. I showed you 2 ways of configuring the native VLAN on a router. Usually, it's best to just set the native VLAN to an unused VLAN, but if you want to use the native VLAN feature, you should know how to configure it on a router. We looked at some Wireshark captures, both the .1Q tagged frame and one that was untagged because it was in the native VLAN. Finally, I showed you the final method of inter-VLAN routing, using a type of switch I hadn't talked about before, a layer 3 switch, also known as a multi-layer switch. By configuring SVIs, switch virtual interfaces, on a multi-layer switch, you can route between subnets and VLANs without having to send the traffic to a router. It's like having a mini router within the switch. These last 2 topics, DTP and VTP, will be left for the next lecture video. Let's move on to today's quiz. As I mentioned at the beginning of the video, I'm happy to announce that after my usual quiz, a few simple questions to help you review what we've learned, I will be featuring one question from Boson's XSIM, which is a fantastic set of practice exams for the CCNA. I used Boson XSIM for my CCNA and CCNP, and I really think they were what allowed me to pass all of my exams on the first try. If you want to pick up a copy of XSIM, check the link in the description. Let's go on to question 1 of today's quiz. Which two answers are valid options to configure the native VLAN on a router in an ROAS configuration? Select 2. Each answer is a complete solution. Instead of reading out each answer, I'll just let you take a look at each set of commands. Here we go. A, B, C, and D.
Which two answers are valid options to configure the native VLAN router? B.
Pause the video to think about your answer. And remember, there are two valid options. Select 2.
And D.
The answer is B and C. B uses the encapsulation.1q native command on the subinterface. This is one option for configuring the native VLAN on a router. The other option is C, to simply configure the IP address on the physical interface, rather than the subinterface. In that case, you do not need the encapsulation.1q. Okay, let's go to question 2. You create an SVI for VLAN 225 on switch 1, assign an IP address, and enable it with no shutdown. But the interface remains down, down. Which two options might be causing this?
The VLAN.
Select 2. A. VLAN 225 doesn't exist on the switch. B. You didn't issue the switchport mode trunk command on VLAN 225's SVI. C. You didn't issue the switchport access VLAN 225 command on VLAN 225's SVI. Or D. No interfaces in VLAN 225 are up.
A. Didn't you create an SPI? Done. And A and D.
Pause the video to think about your answer. The answer is A and D. In order for an SVI to be up, the VLAN must exist on the switch, and it must have either an access interface in the VLAN that is up, or a trunk interface that allows the VLAN that is up. You don't need to issue the switchport mode trunk or switchport access VLAN command. Let's go to question 3, which will be the last quiz question before we take a look at a sample question from Boson XSIM for CCNA. Which command is used to configure a switch interface as a routed port? A.
Routing.
No switch port. B. IP address, followed by the IP address and subaddress.
No switch port.
C. IP routing. Or D. Switch port mode route. Pause the video to think about your answer.
A. No switch port.
The answer is A. No switch port. This configures the interface as a routed port and allows you to configure an IP address on the interface. C. IP routing is used to enable IP routing on the switch, but it doesn't set an individual interface as a routed port. Let's go on to today's Boson XSIM practice question. We issue the following commands on the Catalyst 2950 switch. Configure terminal, interface fast Ethernet 07, switchport trunk encapsulation.1q, switchport mode trunk, switchport trunk native VLAN 44. Which of the following statements is true regarding VLAN traffic when it is sent over port fast Ethernet 07? Select the best answer. Okay, let's check each option.
VLAN 1 traffic will be untagged. All traffic will be untagged. All VLAN will be tagged. All VLAN traffic will be untagged. Traffic will be tagged. Which port trunk native VLAN? All VLAN traffic will be untagged.
A. VLAN 1 traffic will be C. Untagged.
DT.
Okay, so I think the correct answer is B. Because you issued the switchport trunk native VLAN 44 command, traffic in the native VLAN will not be tagged when it is sent over a trunk interface. So, the VLAN 44 traffic will be untagged. Let's check. Click Show Answer down here. As you can see, B is in fact the correct answer. Let's check out Boson's explanation. Traffic from VLAN 44 will be untagged when it is sent over port fast Ethernet 07. VLAN 44 traffic is untagged because it has been configured as a native VLAN by the switchport trunk native VLAN 44 command. By default, the native VLAN is VLAN 1. So by default, A would be the correct, but we changed it to 44. You can issue the switchport trunk native VLAN ID command to change the native VLAN. Okay, here are explanations for why the incorrect option is incorrect. It also says you can issue the show interfaces trunk command to display the list of ports that are configured for trunking, the native VLAN for each port, and list of currently allowed VLANs for each. And here's an example down here after we have changed native VLAN to 44. Okay, there are also references here to Cisco's official cert guide, Volume 1, Chapter 8, about Ethernet Virtual LAN, VLANs, and some Cisco documentation. I will leave links to these in the description of the video. So if you want some further reading about VLAN trunks, .1Q, please check those links in the description for further reading. Okay, so that's all for today's Boson XM practice. If you want to get a copy of Boson video, there will be a review flashcard deck.
Cards. Don't run every party in LA. 4, 3, configure the native VLAN on the router sub interface. Encapsulation .1Q. Native VLAN number, VLAN number, native. What is another name of a layer 3 switch? Multi-layer switch. What is another name for a multi-layer switch? Layer 3 switch. On this virtual interface, you can assign address to on a multi-layer switch. SVI or switch virtual interface. What does SVI stand for? Switch virtual interface. Reset an interface to its default configuration. Default interface. Enable layer 3 routing on a multi-layer switch. Layer 3 routing, layer switch, no switch port. Configure a switch interface as a routed port. No switch port. SVIs are done or the default. Enable layer 3 routing on IP routing. Configure the native VLAN on a router sub interface. Encapsulation.1b VLAN ID native. What is another name of layer 3 switch? Layer switch. Reset an interface to its default configuration. Default interface name. What is another name for a multi-layer switch? Layer 3 switch. Configure a switch interface as a routed port, no switch port, and SVI. Switch virtual interface. Shut down. The switches will take frames sent out of ports. Take frames. Run. The normal VLAN range 1 to 4. VLANs reserved and cannot be used. VLANs 0 and 1008.02.1 plus the DEI drop eligible the extended VLAN range is 10,000. Normal VLAN range 1. What is a proprietary ISO? The default native VLAN is VLAN. Default native VLAN What is a standard VLAN? DEI field is 1 bit. The switch does not add and but one tag to frames the VLAN of the dot one to tag is 34 bytes. Switch receives tag frame on a trunk port. Assume frame belongs to the binary VLAN. Dot one queue tag. The TPID field is always set to value of zero. Dot one queue tag. What does VID stand? VLAN ID. Configure the interface as a trunk port. Switch port mode trunk. One key. The field is used for a class of PC. Bigger than population type of trunk port. Which port trunk load with port trunk encapsulation. Dot one queue tag is the source address field of the Ethernet header. Dot one queue tag. The field indicates that a frame can be dropped if the network gets to the top visible indicator. Display all trunk ports to show interface trunk. VLANs. Ports are known as ports. Trunk. Configure the allowed VLANs on a trunk port. Which port trunk allowed VLAN ID? VLANs. Ports are known as untagged port access. Bigger than encapsulation type on a trunk. Which port trunk encapsulation type. The range of visible VLANs is 1 to 4,000. For security purposes, it's best to change the native VLAN to an use VLAN. Dot one queue tag. That's PCP. Priority port point. Configure the native VLAN on a trunk port. switchboard, trunk, trunk, villain ID, or trunk, villain. With one Q tag, the TPID field is 10 bits. With one Q tag, the field identifies the villain frame belongs to. Configure the VLAN number on a router subinterface. Bar. Configure the radio VLAN on a trunk port. Configure the radio VLAN switch port. Arif VLAN ID. TCP field is 3 bits. It's router on a stick. It involves configuring VLAN tags and IP address. Subinterface. Configure the VLAN number on a router subinterface. Encapsulation .1 key. VLAN .1 tag. What does TPI tag? Does the DEI stable indicator? The default native VLAN is normal VLAN range 1000. The switch does not manipulate. Native VLAN. When a switch receives an frame port, it assumes the frame will be standard VLAN range in 6 to 1000. Figure the interface switch port trunk. Figure the encapsulation type and port. Switch port trunk encapsulation and encapsulation type. Display or trunk ports. Show the allowed switch port trunk load VLAN switch port trunk For security purposes, it is best to choose binary villain. Error on a stick involves configuring villain text and address on another interface. Configure binary villain on a trunk port. Which port? Trunk. Binary villain ID. Configure the villain number. Other station. What are the 5 villains that exist by default? Villain 1, villain configure a switch interface to be an access port. Which port not access? Which port which carry multiple VLANs are called as trunk port. Create a VLAN. VLAN number. Figure the name of VLAN. Name and name. And port is which port which belong to the single next to PC. The VLAN of a switch switch port access VLAN. Will a layer to switch forward traffic. VLANs are used to split up broadcast. VLANs operate at layer 2 timer. But VLAN are Cisco's is in by so I was kinda forgetting all my last lab that I use. I want to practice it more for the last VLANs part 2. You can configure it as the step is shown this step. For the one, configure the switch interface connected to PS access port in correct VLAN. Switch on the go to the interface. So yep. Which port S which port S VLAN 10 interface the port mode access which port access VLAN. VLAN on switch to interface and zero, two, three, plus equal and configure the connection between switch 1 and switch 2, etc. Going on VLANs. Configure the unused VLAN as the native VLAN. Ports the native VLAN. Paste D01 switch port terang. Switch port terang. Port terang. Load VLAN 10 30. Switch port terang. Native VLAN to 1001. To the native VLAN terang ports. Paste D01 switch port terang. Port terang. Port terang. Load VLAN and there was no VLAN 20 that we configure on switch 1 as a trunk port, so we excluded for the VLAN 20 on this switch 2 configuration. Enter. Now we configure VLAN 1001. Make sure all necessary VLANs exist on switch. Use if press D01 and do show interface on. Runs allowed on trunk. Runs allowed and active in the management domain. So for the switch to, we have to create the VLAN 30, so it can be allowed and active in management domain. So we gonna simply type VLAN 30 here and do show interface and trunk. You can see the VLAN 10 and 30 has already been appeared on the VLANs allowed and active in domain. And now we have to configure the connection between switch 2 and R1 using a router on the switch. Assign the last usable address of each subnet R1's subinterface. Here we also have to configure the G02 interface as a trunk port. Set interface G02. Switch port trunk. Switch port trunk. Out VLAN 10, 20, and 30. switch port from Arif VLAN 1001. Okay. And now we configure the subinterface to perform the inter-VLAN routing. Other one, we figure the face 00, no shutdown, interface G00 and encapsulation 1 key dot 10 for the VLAN 10. Type VLAN 10 here. And the IP address 192.168. 198. 468 and 0 60 255 55255.190/26. Okay. For next interface, VLAN 2 address and 6 press G0 version 30 address and 0.0.198 public 255.192 in already signed the that is a protocol up. So this send the license press submit test connectivity by ping with purpose via this we already completed.
Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment and share the video. Let's spread this free series of videos. Thanks for your help. Also, remember to download this practice lab from the link in the description and try it out yourself in Packet Tracer. If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Packet Tracer, but it's even better. You can use it up to CCNP level even, whereas Packet Tracer is too limited to do much beyond CCNA level. Here, you can see all of the labs available for NetSim for CCNA. These are all detailed, guided labs that not only help you practice what you've learned, but really test your understanding. So I think NetSim is a fantastic study tool for the CCNA. If you want more practice relevant to what we're covering now at this point in the course, look here in the Network Access section. VLANs, trunking, this is all stuff you've been studying over today, except Switch 2 has been today's lab. First off, all of these devices are pre-configured, so they are like they were at the end of day 17's lab. Except Switch 2 has been replaced with a layer 3 switch, aka multi-layer switch. So all of these hosts are already in the correct VLANs. Switch 1 and Switch 2 are connected with a trunk, and R1 and Switch 2 are connected using router on a stick. So what we'll be doing is changing this router on a stick configuration to do inter-VLAN routing via SVIs on Switch 2, just like in the lecture video. Step 1 is to replace the router on a stick configuration with a point-to-point layer 3 connection. I'll start on R1 first. Enter privileged exec mode with enable, and then let's do a few show commands. First, let's check the running config of G00 and its interfaces. Show run. By the way, you can press enter to scroll through the running config one line at a time, or the spacebar to scroll one screen at a time. So the physical interface itself has only the default configurations. All I've done is enable it with no shutdown. Under it, you can see the 3 subinterfaces. Let's check the status of the interfaces. Show IP interface brief. G00 and its subinterfaces are all up. Now let's remove the subinterface. Enter global config mode with cont, then delete the subinterfaces with this command. No interface G00.10. Then hit the up arrow, and let's change this to .20. And one more time for .30. Let's check the config again. Do show run. So the subinterfaces have disappeared. And let's check their status. Do show IP interface brief. Now, this is a difference between Packet Tracer and what I showed in the lecture video. When I do the lecture videos, I use GNS3, which runs actual Cisco iOS software, unlike Packet Tracer, which is just a simulator. On GNS3, the subinterfaces still appear with the status of deleted until you restart the device. But as you can see here, they are immediately removed in Packet Tracer. Now let's configure G00 with an IP address. Interface G00, IP address 10.0.0.194, 255.255.255.252. Okay, that's all we need to do on R1. In the lecture video, I did default interface G00 before configuring the IP address. But that's not actually necessary, since it already has the default settings. Okay, next let's configure switch 2's G102 interface. Enter privileged exec mode with enable, and let's check the config of G102. Show run. There it is. Notice this layer 3 switch requires the switch port trunk encapsulation.1q command. The model of switch used in the previous lab didn't require this. Okay, let's return the interface to the default configuration. Enter global config mode, Alt-T. Then default interface G102. When testing this lab out before, I had to do the command twice for it to work. That might be a packet tracer issue, but I'll issue the command once more by using the up arrow. And next, let's check. Do show run. Okay, so G102's configurations have been removed. Let's configure it. Interface G102. Let's try to add an IP address. IP, then I'll use the question mark. Notice there is no option for address. Why is that? It's because this interface is still in layer 2 mode. Let's put it into layer 3 mode. No switch port. Okay, let's try it again. IP, then question mark. Now we have lots of options here, including address. So let's set the address. Address 10.0.0.193, 255.255.255.252. Finally, let's configure the default route here on switch 2. Exit, and let's check the current routing table. Do show IP route. No routes appear, even though we should have connected and local routes for the interface we configured. Why is that? It's because we haven't enabled IP routing on the switch yet, so let's do that. IP routing. And let's view the routing table once again. Do show IP route. Notice that only a connected route appears, no local route. When I showed you the command in the lecture video, both routes appeared properly, connected and local. So I think this might be an issue with Packet Tracer. A local route should appear here too. Anyway, let's configure that default route. IP route O.O.O.O, O.O.O.O, and the next hop is 10.0.0.194, R1's address. Do show IP route. Okay, the default route has been added. That's all for step 1. Step 2 is to configure the SVIs on switch 2. First off, let's check if the necessary VLANs exist. Remember, an SVI won't have a status of up if its VLAN doesn't exist. Do show VLAN brief. Okay, VLANs 10, 20, and 30 exist. Let's configure those SVIs. It's fairly simple. Interface VLAN 10. Okay, the SVI has been created. Now all we have to do is assign the IP address, the last usable address of the subnet in this. IP address 10.0.0.62, 255.255.255.192. That's it. Let's do VLAN 20. Interface VLAN 20. IP address 10.0.0.126, 255.255.255.192. Finally, VLAN 30. Interface VLAN 30. IP address 10.0.0.190, 255.255.255.192. Fix it. Now let's check if the interfaces are up. Do show IP interface brief. Okay, looks good. The VLAN 10, 20, and 30 SVIs are all up. So our inter-VLAN routing should be functioning now. Let's test by pinging between VLANs. I'll do a ping from PC7 in VLAN 10 to PC3 in VLAN 30. First, in real-time mode, I'll test the ping. Ping 10.0.0.129. Okay, so the ping gets through. I still get questions sometimes about why the first one or two pings fail. That's because PC7 needs to ARP for the MAC address of its default gateway. I've explained ARP in a previous video. Now let's go into simulation mode to make sure the traffic is not routed by R1, but instead by switch 2. And let's try that ping again. Ping 10.0.0.129. Okay, notice that the ping goes to switch 2, and switch 2 sends it directly to switch 1, without having to send it to R1. That's because switch 2 routed it from the VLAN 10 SVI to the VLAN 30 SVI within its own software. Okay, let's return to real-time mode. Finally, just to test if our default route to R1 works, let's try a ping to an address in the internet, 1.1.1.1. Note that I already configured static routes on R1 and the internet router, so you don't have to configure anything else. Let's try that ping. Ping 1.1.1.1. Okay, so the ping to the internet works as well. That's all for this lab. Okay, let's move on to today's next.
For this day 18 lab, we want to figure the multi-layer switching. So for the switch 2 that we configured for the last type, change it to the multi-layer switch, and we have to do the inter-VLAN routing, the SVI interface. So for the routing sim, it will not be forwarded to R1s according to the VLAN number. It will be routed in the switch area that perform inter-VLAN routing itself. So when the PC5 want to ping PC2, it will not through the R1s, it will be through switch 2, switch 1, and goes through the PC2 as a destination. We have to configure that. I have to written the steps here. So for the first step here, want to delete the sub interfaces on R1s first. As you can see here, to show IP interface, have to enable it first. To show IP interface brief. So for the last configuration, it will be saved as the sub interface 10, 20, and 30. We have to remove this configuration first. For the no shutdown command, no interface. Push D D00 now we want to assign the IP address to switch to. Paste G00 IP address and 0.0. Five 255.252. Click to show if you can see here the gigabit 00 already configured for its IP address. So the status is top up. Switch to, we have to remove the default configuration. You know, the switch to will carry all the multiple VLANs through its trunk ports to G102. Show interface trunk, and for the port G102, we have to remove that to default. This G102 default. This default is G1. And the interface gigabit Ethernet 102 already set to default configuration. We have to connect it to R1s via G102 and make it layer 3 switch. For the no switch port command, and assign an address that match R1's IP address. Enable IP routing to. We have to make it vertical switch port. Okay. 102 switch port. And 0.1 5.2. show interface wrong. Already remove the configuration for a trunking protocol from G102. We will see the show VLAN brief. Now we will show IP route. See the routing and default gateway is not set because we didn't enable the IP routing. For the switch SVI interface, we will enable it by IP routing and see the show IP route. The connected and local route already stored in the routing table. Now we have to configure the default route to R1 site. IP route to 0.0.0.0 0.0.0.0. The next hop is R1 site 10.0.0.194. Static route via 10.0.0. And now we want to create the SVI for performing the inter-VLAN routing. The switch section, if the VLAN do show VLAN brief. VLAN 10, 20, and 30 is still there. Figure the SVI interface VLAN 10 it is up. We trace and 0.0. The (62) 255.255.255.1. Interface VLAN 20 IP address 10.0.0.26 55.255.255.1. That's it. Face VLAN 30. IP address 10.0.0.1 any 55.255.255.1. And now we check IP to show IP interface brief. You can see our interface is already set and the state is up. Configure SVIs on switch to 1 for each VLAN. Assign the last visible IP address of each subnet to appropriate SVI. Test inter-VLAN connectivity by pinging between VLANs. Test connectivity to internet by pinging. And now we have to pinging and perform the inter-VLAN routing to each PCs in here. So for the example, I want to ping from PC 5 from VLAN 20. So it's IP will ping to VLAN 30. Ping 10.0.0.129. Okay, so the ping is already success and connected. Now we gonna ping to internet because we already do the IP route to the G102 interface. So it must be pinging to the internet. Okay, the ping is with operation without seeing the interruption. So for this interface, I'm gonna remove the level empty to show interface. So I can brief remove the sub interface. No interface D0 mining 40. Sorry. Interface G00 IP address 194 255.255.255.192 252. We're going to switch to enable on C. So have to remove our default configuration is on 0 because it carries multiple VLAN through its trunk ports to make the switch uh, to the interferon routing itself. Now we want the ports to the layer 3 ports. So now switch port G102 the switch port side IP address 10.0.0.3 5.250 and route all the routes to the internet are once interface. We will gonna enable IP routing. Check the IP route. Route 0.0.0.0 with 168 through its R1's address 10.0.0. To the direct routes. Now we have to configure the SPI interface for each VLAN. VLAN 10 IP address and 0.0.0. Public exit interface. Yeah. Zero 120. It must ping. Okay.
in live preview. What I've chosen for today is inter-VLAN routing 2. And I've already loaded up, so let's get started. The network topology is the same as last time. One router, 2 switches, 4 PCs. But instead of setting up the network, we will troubleshoot some problems on the network. So there are 3 lab tasks. Task 1, verify and correct workstation configurations. These are the PCs. Task 2, verify and correct switch configurations. And task 3 is router configuration. So I think for today's preview, we'll do task 1 and task 2. So task 1, a user has reported that PC3 is unable to ping any other device on the network, including devices that reside on the same VLAN as PC3, which is VLAN 10. Okay, so it looks like the devices in VLAN 10 are PC1 and PC3, and VLAN 12, PC2, and PC4. And VLAN 12, PC2, and PC4. Okay, 1 and 3, VLAN 10, 2 and 4, VLAN 12. Okay. 3, VLAN 10, 2, and... Okay, 1 and 3, VLAN 10, 2 and 4, VLAN 12. Okay, and then there's more explanation. All steps in this task should be performed on PC. Okay, let's go to step 1. Verify the problem by attempting to ping every other IP address on the network. All pings should fail. Okay, I won't ping every address, but let's go on PC3. So right one, sorry. PC3 console. There we go. And let's ping the default gateway, which is 192.168.100.1. This subinterface on router 1. And the ping should fail. Yeah, looks like it's failing. Okay, I'll stop that. How about PC1 in the same VLAN, 100.2? Yeah, that's failing as well. And let's do one in VLAN 12.130, which is PC2. Okay, so all the pings are failing as expected. Step 2. According to the network documentation, PC3 should operate in VLAN 10. Verify the IP address configuration. Okay. So here is the correct configuration for PC3. Let's see what the actual current configuration is. ipconfig/all. IP address is correct. Subnet mask should be /25, ending in .128, but this is /24, ending in .0. So that is incorrect. The default gateway is correct. Okay, so the IP configuration is not correct. Correct any IP address configuration problems you find. So the way to set the IP address for a PC in NetSync is this command here. Note that this is just for PCs in NetSync. ipconfig/IP, IP address subnet. Okay, 192.168.100.3, and then the /25 prefix line. And let's confirm our config. Okay, let's see. Attempt to ping every other IP address on the network. Do all the pings succeed now? Okay, let's do some more pings. How about the default gateway? 100.1. Okay, still fails. About PC1. Okay, that still fails, and we'll do one in VLAN 12, P2. Okay, that still fails. I'm using Control C to stop this thing. Okay, so we corrected the IP address configuration, but that didn't solve the problem. Okay, task 2. After verifying PC3's configuration in the previous task, you should begin examining other devices on the network to determine whether other problems exist. Okay, so step 1. List 2 or more causes of inter-VLAN routing problems on layer 2 switches. Okay, so this is something I really like about NetSim. It really tests your understanding by asking good questions like that. So what are 2 possible problems? Okay, one could be perhaps the PC is in the incorrect VLAN. It's supposed to be in VLAN 10, maybe it's in VLAN 12 or a totally different VLAN. So that's one possible cause. Let's do one more. How about, this is probably a trunk connection between the 2 switches, or it should be. You might have forgotten the switchport mode trunk command, or perhaps the correct VLANs are not allowed. So maybe VLAN 10 is not allowed on this. Therefore, PC3's traffic cannot pass between the 2 switches. Okay, so those are 2 possible causes. According to the network documentation, PC1 resides on the same VLAN as PC3. From PC1 and PC3, attempt to ping each subinterface on router 1. What can you surmise from the results of these pings? Okay. So first from PC3, well, we already tried the ping, but I'll just do it one more time. 100.1. This subinterface not be pinged from PC3. Did it say both subinterfaces? Yes, each subinterface on router 1. Okay. So the subinterface for VLAN 12 did not work also. .129. Okay, yes, the ping fails. Now let's try from PC1, also in VLAN 10. 192.168.100.1. Okay, the ping works. How about the other subinterface? It works as well. Okay, so PC3 cannot ping either subinterface. PC1 can ping both. So what can you surmise from that? Well, I'd say the problem is either on switch 2 or in the connection between switch 1 and switch 2. Because switch 1 seems to be able to route between the VLANs, no problem. Or switch 1 doesn't do the routing, but router 1 does the routing here. But PC1 can ping through switch 1 to router 1. PC3 cannot though. So there's either a problem on switch 2 or on either switch 1 or switch 2 on this trunk connection here. Okay, next one. On switch 1, display VLAN information. The ports are operating in the same VLAN as PC1 and PC3. Okay, switch 1, console. Enable show VLAN brief is the command we want. So VLAN 10 is the VLAN. Only fast Ethernet 03, which I believe was PC1 VLAN. Yes. So this configuration seems fine. Yeah, so the answer is fast Ethernet 03. On switch 1, display interface trunk information. Which VLAN is the native VLAN and which ports are trunk ports? So interfaces trunk. Okay, so as expected, fast Ethernet 01 and 02 are trunk ports, and the native VLAN is 1 on both, the default native VLAN. Okay, and then go to switch 2. Switch 2, enable show VLAN brief. Okay, so no ports are in VLAN 10. Fast Ethernet 03 and 04 are both in VLAN 12. Okay. Let's go to number 6. Based on the topology and IP address configurations, which ports on switch 2 should be operating in VLAN 10? That is probably Fast Ethernet 03. Yes, it is. So here is an issue. PC3 in VLAN 10, or should be in VLAN 10, but it is currently configured in VLAN 12. And its subnet is also the VLAN 10 subnet. So I think we're going to have to change that. There we go, step 8. Or sorry, step 7. What mode is switch to fast Ethernet 03 port in? Okay, so this is a command that I haven't showed you yet. Show interfaces F03 switch ports. I don't think I showed you it yet. Administrative and operational mode are both static access. So this is an access port. You can configure with the command switch port mode access. So that's the answer to number 7. Access with the and so interfaces F03 switch ports. I don't think I showed you it yet. Administrative and operational mode are both static access. So this is an access port. You can configure with the command switch port mode access. So that's the answer to number 7, access mode. Number 8, correct the VLAN configuration. Okay, so that is easy. Conf T, interface F03, it should be in VLAN 10. So switch port access VLAN 10. And then number 9 is verify the new VLAN configuration. Do show VLAN brief. Okay, that's better. Fast Ethernet 03 is in VLAN 10. Next, number 10, on switch 2, display interface trunk information. Okay, do show interfaces trunk. So Fast Ethernet 01 is a trunk. That's correct. Native VLAN is 1, same as switch 1. And I didn't point this out on switch 1, but all VLANs are allowed. The allowed and active VLANs are 1, 10, and 12. So same as switch 1. So the trunk configuration here actually looks fine between the two switches. Okay, next, on PC3, do some more. So same as switch 1. So the trunk configuration here actually looks fine between the two switches. Okay, next, on PC3, do some more pings again. Do all the pings succeed now? Let's see. So first, the default gateway. Okay, the thing works. It looks like that VLAN issue was the main problem. How about PC1 in the same VLAN? Yep, looks good. How about PC2 in VLAN 12? Okay, it does not work. How about PC4? Okay, PC4 doesn't work either. Okay, so there's definitely an issue there. From PC2, attempt to ping every other device in the topology. Okay, PC2 is in VLAN 12, connected to switch 1. Let's open the CLI here. First, ping its default gateway, 100.129. Okay, PC2 cannot even reach its default gateway. How about PC4 in the same VLAN? Okay, this works. So it can ping the other PC in the same VLAN, but it can't ping its default gateway. How about PCs in other VLANs? It shouldn't be able to reach them because it can't reach the default gateway. Yeah, as expected, it doesn't work. Okay, so clearly we still have an issue here. So PC3 seems to be operating fine, but PC2 can ping PC4 in the same VLAN, but it can't ping its default gateway, which is the subinterface here on router 1. So clearly an issue still remains in the network. So I think we will solve those issues here in task 3, but I'll leave it here for today. If you want to pick up a copy of NetSim for yourself, please follow the link in the description. I highly recommend it. It's great additional practice for your CCNA. And as you can see, there are plenty of labs from network. Welcome to Jeremy's IT Lab. This is a free, complete course for the CCNA. If you like these videos, please